Hello, and a very warm welcome to everyone who is tuned in to this webinar today. My name is Suman Bhatt, and I work as a sub-segment manager at AkzoNobel. Today, I will be taking you through a review of the ISO 12944 standard and explaining the changes that have taken place in the recent revision of the standard that took place in 2017-2018. This is part of a series of webinars that we at AkzoNobel will be bringing to you over the course of the next few weeks. So please do ask your AkzoNobel representative for more information if this is of interest to you. Before we begin, a quick comment here to say I will be using the terms paint and coating interchangeably throughout this webinar. And in this context, they both mean one and the same. That is, as a layer of liquid applied material that is used to protect the substrate from corrosion. The agenda for today's webinar is as follows. We start with a quick introduction of the ISO 12944 standard, its objectives, and applications of the standard. We then move on to the salient differences in this, the third edition of the standard, compared to the previous edition published in 2007. We move on to the question of testing and talk about where third-party or independent test reports are necessary. In the next section named New Product Innovation, we explore more in depth the allowances that the standard has made to innovative products that may differ in chemistry from what is recommended in the standard, but nonetheless provide as good or better protection. I'll end the webinar with a summary of what we've covered today and leave you with a link to our website where you can get in touch with us for further details about today's webinar or indeed any questions that you may have related to coatings or corrosion protection. In this section, we will have a quick recap of the ISO 12944 standard to refresh your memories. So to start with a quick refresher of the ISO 12944 standard, it was first introduced in 1998 as an 8-part standard, and it deals with the protection of assets by paint and coating systems. The new revision, which was published in 2017-2018, comprises of 9 parts. It is currently the most widely recognized global standard for specifying paints or coating systems that provide protection from corrosion and is used across all major markets in protective coatings. The standard provides guidelines on the following: corrosivity categories or environments. Part 2 and Part 9 of the standard deal with classification of environments into corrosivity categories. The standard covers recommendations for atmospheric exposure, fresh and seawater immersion, as well as buried service. Design considerations. Part 3 of the standard deals with the basic criteria for the design of steel structures to be coated with paint systems in order to avoid premature corrosion and degradation of the coating or substrate. Surface preparation. Part 4 of the standard covers recommendations for surface preparation to minimize the risk of premature failure of the coating system. Paint systems. Part 5 of the standard gives recommendations for paint systems to be used in a given environment for a given durability. This section has gone through a significant change in this revision of the standard, and we will be covering that in greater detail during this webinar. Test methods. Part 6 of the standard covers laboratory test methods, and this is another section that has been significantly changed in this revision. Again, something we will cover further in detail during the course of the webinar. Part 7 covers execution and supervision of paintwork. And Part 8 covers guidelines for development of specifications. The standard is meant to be used by those who have some familiarity with using or specifying coatings for corrosion protection. Typical users of the standard would be people working in asset owner organizations, such as facility managers, project engineers, or materials engineers. It could also be used by project managers and engineers in engineering and construction companies, and they could use it for selecting or specifying coatings for the projects that they're involved in. Consultants involved in coating specifications may also refer to the standard when writing specifications for projects. Paint applicators and paint inspectors may use the standard both for selecting appropriate products and also to refer to surface preparation and application guidelines, which is covered in Part 4, and the supervision and inspection, which is covered in Part 7. And of course, paint manufacturers use the standard to ensure their products are in accordance with the standard and are relevant to the markets that they serve. A quick reminder that the standard covers corrosion protection for steel structures in atmospheric, immersed, and buried service, coatings that are used for concrete and other non-metallic substrates, coatings for high temperature service, and coatings for chemical immersion and other uses such as pacifier protection are not part of the scope of this standard. Onto an overview of the standard. In the broadest terms, the ISO 12944 standard makes use of the following three parameters when recommending systems for corrosion protection of steel structures. Durability. This is the expected life of the coating system up to the first major maintenance. It is assumed that regular coating inspection and minor maintenance will always be required throughout the structure's life. Corrosivity, the ability of an environment to cause corrosion, and the standard classifies environments into categories based on their potential to cause corrosion to unprotected steel. Coating system specification. The standard provides a guideline in selecting paint systems that will provide protection to meet the expected durability given the corrosivity of the environment. Each of the above parameters have had some significant changes to them in the latest revision of the standard, and that is what we will be covering in greater depth in the next section. So in this section, we will be covering the key changes that have taken place in revision 3 of the standard. Since it was first published in 1998, the standard has gone through 2 iterations. The revision 2 was released in 2007, and revision 3, which is the latest one, in 2017-2018. So the first change that we will cover is the one that has taken place in part 2 of the standard, dealing with the classification of environments. The key change here is the removal of the C5I and C5M categories and replacement with a single C5 category that covers highly corrosive onshore environments. So the new standard now has 5 categories for onshore environments ranging from C1, which is very low corrosivity, typically what you would find in a climate controlled interior environment, to C5, which is considered very high corrosivity, such as in a coastal refinery, for example. Another significant change to the corrosion categories in this standard is the introduction of the CX category to cover offshore environments. And this is described in the newly introduced Part 9 of the standard. So a typical offshore asset, such as the FPSO that you see on the right of the screen, would fall into this category. We also have an additional category added for paint systems for use in sea or brackish water in conjunction with cathodic protection. So this slide summarizes the corrosion categories that were in the previous version of the standard as well as the new revision. So as you can see, the third column here shows you which categories were part of the earlier version of the standard, and the rightmost column shows you what it looks like in the new revision. I'll give you a minute to go through this, and just to highlight again, the C5I and C5M have been removed from the new revision and replaced with a single C5 category that covers temperate and subtropical environments with very high pollution or significant chloride effects, essentially coastal and high industrial atmospheres. Introduction of the CX category, which covers offshore areas, and again, finally, the introduction of IM4, which covers immersed structures with cathodic protection. We now move on to the changes that have taken place in the durability category in the latest revision of the standard. Low, medium, and high durability categories remain in the new version, albeit with a slight change to the expected life to first major maintenance, as can be seen here on this slide. In addition, there is a new category now of very high durability, which covers a design life of the coating system for over 25 years. This is in response to an increasing need from asset owners to extend asset life, in many cases over 25 years, and the new revision has catered to that. The table on this slide summarizes the different durability categories as per the previous revision and the current revision of the standard. So as you can see, low durability now takes you up to 7 years, medium durability from 7 to 15 years, high durability from 15 to 25 years, and we've got the very high durability category for design life over 25 years. Next, we move on to coating system specification changes. A few key points to highlight here. First is a change to specified minimums for dry film thicknesses and minimum number of coats. In the previous revision of the standard, these were a guidance, but now it has been changed to mandatory minimums. This is essentially to prevent a race to the bottom, so to speak, with some coating manufacturers previously pushing ever lower DFTs for their products in order to be cost competitive. It was felt that this increased the risk of premature coating failures, and hence the new revision of the standard has been changed to require mandatory minimum DFTs. The 2017-2018 version of the ISO 12944 continues to specify generic chemistry of coats in a paint system. However, it does make an allowance for new innovative technologies that don't conform to these chemistry descriptions. Innovative products can now be accepted by the client if the manufacturer is able to demonstrate fitness for purpose by providing third-party laboratory test reports or in-field performance track records. We believe that this is an important change that allows the industry to progress and innovate while ensuring that users of paint systems will still have the assurance of adequate performance. A note here to say that although there are significant changes in requirements for coating systems in the new revision, all systems that were tested in conformance with the previous revision are still acceptable, but these should be referenced as being in accordance with the relevant revision. This is to ensure transparency to users of these coating systems. Last but not least, we will be covering the changes to laboratory test methods. The test criteria for systems up to C4 high durability remain the same as in the previous revision. The key change is for systems used for C4 very high durability, C5 high durability, and C5 very high durability. For these systems, cyclic corrosion testing has been introduced. We at AkzoNobel welcome this addition to the standard, having found over many years that cyclic testing is more representative of real-world corrosion conditions. Our internal research has shown that static tests, such as the salt fog test, do not correlate very well with the performance under real-world conditions. The table here summarizes the changes that have been implemented to testing of paint systems. As you can see, non-cyclic testing of 480 hours of condensation and 720 hours of neutral salt spray remain for systems up to C4 high durability, as well as for C5 low and medium durability. For C4 very high durability and for C5 high durability, there is a phased introduction of cyclic testing, which means that non-cyclic tests will still be accepted for the first 5 years that this standard is in place, after which only cyclic tests will be recognized. For C5 very high durability category, there is an immediate introduction of cyclic testing. The pictures on this slide are an example of one of our systems being evaluated in accordance to the new revision of the standard. On the left is a photo of panels of the system after undergoing the cyclic corrosion test for C5 very high durability. And on the right are some panels of the same system being tested at a coastal exposure site that we have here in the UK. Our experience over the years has shown that cyclic corrosion testing correlates much more closely to real-world performance than static corrosion testing. In this section, we will go through a sample of some of our systems that have been tested and approved in accordance with the new ISO 12944 revision. On this slide, we have a selection of our coating systems for C3 environments. As you can see, we have both single coat and two coat options for C3 environments for all durability categories. The single coat options using our Intercure 4500 or Intercure 99 products is based on polyaspartic technology, which combines excellent corrosion protection with exceptional aesthetics in terms of gloss and color. Our two coat options are a standard epoxy primer followed by a polyurethane top coat. Next, we have our systems suitable for C4 environments. Here again, for C4 medium durability, we have a single coat system using our polyaspartic products, Intercure 4500 and Intercure 99. For C4 high and C4 very high durability requirements, we have options using a two coat or a three coat scheme. I'll give you a moment to go through the details of the schemes on this slide. Next, on to the C5 environment schemes. Here again, we have options with either two coat or three coat systems across medium, high, and very high durability requirements. The systems marked with an asterisk are ones that make use of the clause in the standard, allowing for innovative technologies to be used as long as they are certified using third-party test labs and demonstrate good track records. All the systems that are shown on this slide, as well as the previous slides, are backed up with test reports from accredited third-party labs, and these are available to our customers on request. Again, I'll give you a moment to go through the systems on this slide, which include systems both with a zinc-rich primer as well as some of our non-zinc epoxy primers. Next, we go on to cover the allowance that the standard has made for new innovations in coating technology and how we at AkzoNobel are incorporating that into our new product launches. As mentioned previously, the new revision of ISO 12944 allows for new innovative technologies to be used when backed up by test data from third-party labs to demonstrate its fitness for purpose. We will be bringing to market a number of such innovative products over the next several years, and these will be tested in accordance with ISO 12944. One such product that we've launched last year is InShield 4000 USB. This is a zinc-free universal primer for structural steel, which has demonstrated performance equivalent to zinc-rich primers in cyclic corrosion testing. It is a potential game changer as it brings huge value to our customers in terms of productivity and reduced specification complexity compared with zinc-rich primers. We have tested several schemes with InShield 4000 USP as a primer for various environments and various durability requirements as shown in the table on this slide. The third-party testing has shown that the performance of these systems is comparable to similar systems with a zinc-rich primer. This also correlates with atmospheric exposure testing that we've carried out at several of our coastal exposure sites. Please do get in touch with us if you'd like more information regarding this product or indeed any of the others that were shown in the previous slides. A quick summary of what we've covered in the webinar today. We covered the new revision of the ISO 12944 standard that was released in 2017-2018 and the key changes from the previous revision. To recap, we have key changes to the classification of environments where CX has been added for offshore environments, as well as IM4 for seawater immersion with cathodic protection. Cyclic testing has been included for C4 very high, C5 high, and C5 very high categories. Minimum DFTs are now mandatory minimums rather than informative as was the case previously. The standard also does make allowances for innovative or novel technologies that may differ in the chemical composition or DFTs from what is prescribed in the standard. Previously tested systems still remain valid, but the relevant revision of the standard must be referenced when using these systems. We also went through a selection of systems that AkzoNobel have tested in accordance with the new revision of the standard. And if you would like any further details of these systems, please do get in contact with us. Thank you very much for joining our webinar today about the new revision of the ISO 12944 standard. Please do visit our website, international-pc.com, where there's more information about this standard, our coating systems that conform, as well as many of our other products and services that are available to you. Thank you and wish you all the best.